Hello students, we are going to discuss the next topic of conic sections, that is parabola. First let us look at what is the definition of parabola. A parabola is a set of points P whose distance from a fixed point F in the plane are equal to the distance from a fixed line in the plane. The fixed point is called focus and the fixed line is called directrix of the parabola. If we want to look at the diagram, the parabola will take shape like this, where F is the focus and this L is the directrix here. In case of circle, we saw there were only one fixed point, but here in case of parabola there is a fixed point and a fixed straight line. You can see in your textbook they have broken the parabola into two parts, para and bola, means it is the part when an object is thrown in the space. So, this is what is illustrated by this diagram. If we throw a stone or something, pebbles like this, it always traverses a path like this. So, a parabola is a curve where any point at an equal distance from the parabola, where at any point is a equal distance from a fixed point and a fixed straight line. You can see in this diagram also, this is the focus and this is the directrix. Focus is the fixed point and directrix is the fixed straight line. And if suppose you take a point over here, whatever is distance from this point, the same distance will be from the directrix also. Some other parts of the parabola, already directrix and focus it is explained above. The axis of symmetry, this line is called axis of symmetry, which passes through the focus at right angles to the directrix. It is a right angle to the directrix, so this is called axis of symmetry. And the point where axis of symmetry cuts with the parabola, it is known as vertex, as you can see here in the diagram. What is the standard equation of parabola? Suppose we append the origin at the vertex. This F is the focus, which is at a distance of a from the origin on the x-axis. So, directrix will be also at a distance of a. So, equation of the directrix will be x equal to minus a, focus will be a 0. So, for this kind of parabola whose vertex is at the origin, focus is at a 0, is given by y square equal to 4ax. So, this is the standard equation of a parabola when x-axis is the axis of symmetry and focus it at a 0. It could be other way round also. Suppose the focus is at minus a 0 and vertex remains same at origin only. In that case, directrix will be x equal to plus a. So, in this case y square equal to minus 4ax. So, the first kind of parabola we are going to refer as right parabola, where the focus is at a 0. And you can see if focus is at a 0, the parabola looks like opening its mouth on the right side, and this is known as left parabola. Similarly, the focus could be on the y axis also. Its focus is at the y axis and the vertex is at the origin, because we are supposed to discuss the standard equations. In that case, it is x square equal to 4ay, and when it is focus it is at 0a, then it would be x square equal to minus 4ay. In future, whenever we will talk about upward parabola, it will be x square equal to 4ay, and downward parabola it would be x square equal to minus 4ay. So, in both the cases you might have observed, whenever it is x square is there, the parabolas are symmetric about y axis. The previous cases mein what we saw, when the y square is there, the parabolas are symmetric about the x axis. So, one more thing we need to discuss, the latus rectum of parabola. Latus rectum of a parabola is a focal chord which is passing through the focus and is perpendicular to the axis of the parabola. The latus rectum cuts the parabola at two distinct points. For this parabola, we have taken the right hand parabola, the length of the lattice rectum is 4 units, the endpoints of the lattice rectum is A and 2A and A minus 2A. Let us look at the diagram. So, this is what I was talking about. This is a right parabola. So, L dash is the lattice rectum. So, here if we put x equal to A, so this will become 4A square. So, y square equal to 4A square. So, y will be plus minus 2A. So, this point is 2A, this point is minus 2A. So, this length is 4A. So, in all the standard form of parabola, the lattice rectum is always 4A, whether we take the right parabola or left parabola or upward parabola or downward parabola. In all the 4 cases, length of the lattice rectum is always 4A. So, this is the table which you are supposed to draw in your notebook also. This table with all the facts. What you see here, this is the right parabola, left parabola, upward parabola, downward parabola. And here what is the axis? X axis matter y0, y axis matter x0. Directrix you can well understand. This is on the left side of y axis, so x equal to minus a. This directrix is on the right side of y axis, so x equal to a. This directrix is below the x axis, so y equal to minus a. It is above the x axis, y equal to a. Vertex all are at origin. Focus already explained. Length of the lattice rectum already explained. And equation of the lattice rectum is your x equal to a, x equal to minus a. It will pass to the focus actually. Wherever focus will be there, you see a0, so lattice rectum is x equal to a. Focus minus a0, x equal to minus a. Here 0a, so equation of lattice rectum is y equal to a. 0 minus a, so equation of lattice rectum is y equal to minus a. Then we will see some application of parabola. You might be thinking why you are studying parabola. A parabola has an amazing property. What is the property? Any ray parallel to the axis of symmetry gets reflected off the surface straight to the focus. Matlab, if we draw a line parallel to, it will go to the focus only. Any line parallel to the axis of symmetry pass to the focus only. And that explains why that dot is called focus. Why it is focus? Because any ray of light will pass through this only. Because that's where all the rays get focused. So, parabola can be used for satellite dishes, radar dishes, concentrating the sun's rays to make a hotspot, the reflector on sports light and torches. So, these are the uses of parabola. Now, we sorry, we are in a position to discuss the exercise 11.2. From question number 1 to 6, we have to identify the focus axis of the parabola, equation of directrix and length of lattice rectum. So, the first question, y square equal to 12x. So, if you compare it with y square equal to 4ax, 4a equal to 12, a equal to 0. So, the focus will be a0, 3, 0. Since the given equation involves y square, the axis of the parabola is x axis. Equation of the directrix, x equal to minus a, that is x equal to minus 3, x plus 3 equal to 0, and length of the lattice rectum is always 4a, which is 12. Question number 2, x square equal to 6y, it is a upward parabola. Here the coefficient of y is positive, hence the parabola opens upward. Comparing with x square equal to 4ay, we obtain 4a equal to 6 because a is 3 by 2. The coordinates of the focus is 0a, so 0, 3 by 2. Since the given equation involves x square, the axis of the parabola is y axis. Equation of the directrix y equal to minus a, so y equal to minus 2 by 3, and length of the lattice rectum is 6. Third question, y square equal to minus 8x, that is left parabola. You see, it is a left parabola, so we compare it with y square equal to minus 4x. So, minus 4a equal to minus 8, so a equal to 2. Coordinates of the focus minus a 0, so minus 2 0. Since the given equation involves y square, axis of the parabola is x axis. Equation of the directrix x equal to a, that is x equal to 2. Length of the lattice rectum is 8. Fourth question, it is a downward parabola, x square equal to 6y minus 16y. So, you can see a ka value 4, focus is 0 minus 4, equation of the axis is y axis, directrix is y4, length of the data sector is 16, very easy. And we see that this number 5 and number 6, number 5 is similar to 1, number 6 is similar to your 4. So, I have skipped this 2 question, I am going directly to 7 question. You can see 7 question. In the question number 7 to 12, we have to find the equation of the parabola that satisfies the given condition. So, here the focus is 6 0, directrix is minus 6. So, very easy. If the focus is 6 0, it is a right parabola in the form y square equal to 4ax and x equal to minus 6. So, the left side of y axis, the focus is 6 0, is to the right side of y axis, and the parabola is of the form a is 6. So, equation of the parabola is y square equal to 24x. Next question, focus is 0 minus 3, directrix y equal to 3. So, focus is 0 minus 3, directrix is y equal to 3. Therefore, the focus is on the y axis, the y axis is the axis of the parabola. Therefore, equation of the parabola is either of the form x square equal to 4ay or x square equal to minus 4y. It is seen the directrix is y equal to 3 above the x axis, while the focus is 0 minus 3. Hence, the parabola is of the form x square equal to minus 4ay, a equal to 3. So, equation of the parabola is x square equal to minus 12y. It is a downward parabola. Question number 9, vertex 0 0, focus 3 0, very easy. It is y square equal to 12x. Question number 10, vertex 0 0, focus minus 2 0. It is also very easy, y square equal to minus 8x. Vertex 0 0 passing through 2 3 and axis is along x axis. Here what we will do? It is either y square equal to 4x or y square equal to minus 4x. So, parabola passes through 2 3, which lies in the first quadrant. Therefore, the equation of parabola of the form y square equal to 4x, because it is in the first quadrant. So, putting this value of 2 3 here, we find the value of a to be 9 by 8, put it back, we get the equation. Question number 12, vertex 0 0 passing to the point 5 2, symmetric with respect to y axis. So, x square equal to 4ay, because it is passes through 5 2, which is in the first quadrant. So, putting the value of 5 2 in x square equal to 4ay, we get the value of a to be 25 by 8, put it back here, we get the equation of the parabola is 2x square equal to 25y. So, hope you understand all these solutions. Thank you so much.